yesterday we got our product rule, which remember was this. So if I'm taking the derivative of two things that are being multiplied together, take the derivative of the first times the second plus the first times the derivative of the second. And we looked at an example of that. Yes? Yes. And then we needed to look at our next one?
Yes.
Yes. Okay. What's different about this one? Trig functions, yeah, so that's one thing that's different. And so remember yesterday, the one that we looked at, we technically could have distributed our square root of x, right? And we could have used our power rule, but in this case, there's not another rule we can use. Like, we have to use the product rule because there's not a way to use the power rule for your trig functions. What's the other difference? There's three of them. So let's make it, what letter do we want it to be? G, H, and V.
B.
D. V? V of T?
I don't like that. I'm not a fan.
Okay.
S of V.
I would rather not introduce
S
two new
of X. There you go.
Yeah.
Yay!
Okay, so we can technically apply our product rule with as many functions as we want. Okay, however, the max that we're going to deal with in here is going to be 3. And for the most part, on our AP test, you're really only ever going to deal with 2. However, if you can do 3, then we definitely should be able to do 2. The only big difference here, so I'm going to write out the formula just so we can kind of see that first, and then we'll actually take some derivatives. So if I'm looking for my derivative, okay, so remember that last time we would take the derivative of our first one and multiply it by the second one. Agreed?
Yeah.
This time we just have to add in the last function. Then I'm going to add, okay, and I'm going to move to the next one. I'm going to take the derivative of the second one, but multiply just the other two. And then this time, we also have to add in taking the derivative of the last one while multiplying by the other two.
That makes sense.
And if I had more, I would just continue down the line. I would take the derivative of the next one and add it, multiplying by the other things, and so forth. Okay? That kind of makes sense?
Yes.
So, now we just need to write out our derivative so we can plug in, because we already have all of our original functions. So, what is our derivative of G? Okay. What is our derivative of H? What is our derivative of S? So then we're just going to apply that. So I have the derivative of G is 2x. Sine x times cosine x. Then I'm going to add, and I'm going to leave my x squared the same. And multiply by cosine, cosine. And then lastly, add x squared times sine times my derivative of x. Okay, so we have some stuff that we can simplify. So how many cosines do I have here? 2. So I have x squared cosine squared x. I have a negative, so I'm subtracting. And how many sines do we have? 2. I technically could factor out an x from everything, but it's not going to be able to reduce. I don't have a trig function in common with everything, so that would be my final answer.
Very long.
Okay.
It's so ugly.
It's supposed to be ugly. It's like one of those ugly vegetables that you find in the big buckets at like Walmart, and you're like, oh, it's so ugly.
And that's why I don't like them.
food boards. They're like all green.
Yeah, I buy the ugly ones because they're sad. I don't want to eat them.
Alright, so now we have looked at addition, subtraction rules, and we've added a multiplication rule. So what's our last one?
Combine them. Oh,
Nope, a
division.
division rule. We gotta have our quotient rule. Again, we have to have this memorized
Why?
because it comes up a lot.
Cry.
Now, I will tell you the way that I like to remember it. So, have any of y'all ever seen Snow White?
Yeah.
With like the little
How?
little people that like work in the mines,
Mhm.
like songs that they sing.
No.
Yeah. So that's what this kind of is. So we have dx. Okay. So you have the top, which we're gonna call high, and the bottom, which we're gonna call low. It's like kind of. It's not like exactly. So we have the derivative. So we just keep our first the same. So it's low d high minus high d low all over low squared. I mean, if you want to make it a song, you can. So it's low d high minus high d low all over low squared.
So,
So if we write high and low in our formulas,
Well, I'm not gonna ask you for the formula.
the formula's
Like,
still
so as
right.
long as well, I mean, if you write this out and as long as you know what this means and you apply the formula correctly, it doesn't matter how you remember the formula. You just have to be able to apply the formula.
Why is?
Why?
Oh.
oh, I see.
The derivative.
I didn't have breakfast this morning.
Yeah, so it's the derivative of the top. It makes it like a low.
Dx low over low squared.
I get it.
Oh.
And if you wanted to make it high over low,
High.
That's it.
Minus high.
alright, we have that down. So let's go ahead and apply this. Alright, so this is just a reminder of our tangent derivative, and then also we need to write out our other last three trig function derivatives. Now I will say these three don't come up near as often. Okay, so if you're gonna memorize any of them, memorize sine, cosine, and tangent. Okay, the other three, it's good to know them. However, we can get away with not knowing them most of the time. But we do have to have sine, cosine, and tangent. We have to have those three numbers. Sine, cosine, and tangent have to be memorized. Because what could I technically do? I could always rewrite my other ones as the reciprocal, right, of
Oh,
the other
yeah.
ones. So like technically we can get away with not memorizing these, but you have to memorize that.
Cosine is negative. Or is it the other way?
The derivative of sine is cosine. The derivative of cosine is negative. Alright, so now let's look at our problem. It says find the derivative of y equals cosine of x divided by x cubed. Would there be a way for us to simplify this? To get away with not using the quotient rule? Nope, there's not. So we have to use our quotient rule. So let's talk about if this is f of x and this is g of x. I'm going to go ahead and write out what is my derivative of f of x. Negative sine of x. What is my derivative of g of x? Okay. So then I'm just going to apply my formula. So I have the bottom times the derivative of the top. So negative sine of x minus the top times the derivative of the bottom all over the bottom Again, doesn't look super pretty. We are going to be able to simplify it a little bit. Okay. So notice I have negative x cubed sine of x. I'm going to go ahead and move my other. So I have 3x squared cosine of x. And then what do I get on bottom? Yep. So then the only thing that we might do here is notice that we can factor out an x squared from the numerator. So I'm left with negative x sine of x minus 3 cosine of x. And then we can reduce that with our denominator.
Thanks.
So then I have negative x sine x minus 3 cosine of x, all divided by x to the 4th. And that would be amazing. Again, we don't want to try and simplify more than that or do weird things, because the more algebra I try and do, the more likely I am to make a mistake somewhere.
That's minus 3x on the top of it, right? Like the x, negative x cubed sine x minus 3x squared.
This is a 2.
Wait, on the exam, could we have stopped at like the x where it's like x?
Yeah. If it was a free response question, yes. Now the only thing that is like if it was multiple choice question, they're probably going to simplify. So you just need to make sure you know how to simplify that.
Just on the multiple choice, they don't use radicals when you they simplify it.
Sometimes. Depends on the problem. It depends on how many radicals there are in the answer.
Usually just one. You're like, and read, so there's pretty simplify it.
You're talking about in the book?
Yeah.
Okay. That's different than what you're talking about. The AP test is much different than what's in your textbook. Alright. So now we're going to evaluate the instantaneous rate of change at x equals pi over 2 for the previous problem. What is instantaneous rate of change? The derivative, right? At pi over 2. So we need to write out our derivative, which lucky for us we already found. So our derivative, I'm just going to rewrite it out. We said was negative x sine of x minus 3 cosine of x divided by x to the 4th. Okay? And where are we evaluating that at? X equals pi over 2. So what am I plugging in? Pi over 2. In for all of our x's. Okay?
Okay.
That's a lot.
So, however, some of our stuff is going to go away, which is kind of nice. Because remember that my so at pi over 2, what is sine at pi over 2? 1. Okay. This is sine of x. This is cosine of x. What is cosine at pi over 2? 0. Okay. So this becomes 1. So I just have negative pi over 2. This becomes 0. So negative 3 times 0 is just 0. And then I have pi to the 4th divided by 16. So then my last step is just going to be to multiply by the reciprocal. So I end up with negative 8 divided by pi to the 3rd.
Yeah.
plug that into our calculator because it's going to give you the decimal approximation of whatever